So day one, we're gonna get a decent amount of stuff done. Tomorrow we'll finish off the remaining stuff. Your homework packets, you can see, maybe you can't, but there's quite a few people who turned them in. And it's because you get a decent amount of work time today, and your homework assignments is not super long. It looks really long, but you find that the work that you need to do is pretty easy. So, first things first, we're going to just talk about inverse operations. When I look at addition, my example to you will be something like this. How would we use the inverse operation of addition to solve that? We would subtract 2. So the inverse operation is simply subtraction. I'll put minus 2 here, but I'm not going to go any further. What's our inverse operation of multiplying? Division, very good. And those two we tend to do very well on, so I'm not going to do much more than that. Powers. If I have, for example, x squared, how do I cancel out that square root? We square root. And likewise, if I have the square root of x, I can square it and also cancel it out. So it works both directions. Exponents. If I have 2 to the x and I have to solve that, at this point, you would guess and check. Right? If I gave you equals like 512 or something, you would have to then go ahead and just guess and check. Thank you. So now we don't have to do that. Now I can take the log of this, and so I would make this log base 2 because that's a base 2, and then these things cancel out, and I am left with simply x. If I would do that inversely, I would have log base 2 with an x, and I would actually raise this whole thing to become an exponent, and I would have 2 to the log base 2 argument x. This would cancel out, leaving me with x. You don't have to die on this hill today, okay? We're just showing you things. And so we're introducing logs to you, and so this chapter, we introduce logs, we graph them, just like we graphed exponential functions. We do a little bit of exponential equations in terms of solving for populations and things like that, and compound interest. And then in your next chapter, we're going to solve and actually show steps like this. So this is all just intro, okay? Really, we're doing this to get to the graph. When I look here, we graphed this yesterday. We're going to graph the inverse. And to do that, we need to start by filling out our table. Yesterday, we had our table, and I'm going to ignore the negative 2. I'm going to start at negative 1. We had negative 1, 0, 1, 2, and I'm going to add 3. And the y's that pertain to that, remember, this would be 1/2. This would be 1, 2, 4, and 8. Again, that was the first one from the note packet yesterday. That's why I'm not taking a lot of time there. What was our asymptote for this? 0, but what letter?
Y equals 0.
Good, so y equals 0. In terms of our intercept, we had an intercept of 0, 1, our y-intercept. For our x-intercept, we did not have that. We just simply had none. Graph it. And we're going to compare these things momentarily. That is our exponential function. We have a base of 2, and we have x as the exponent. Are we good there? We all got it? Okay, now we flip-flop. So if I'm doing the inverse, my y's become my x's, and my x's become my y's. So go ahead and transfer. So these y's go right here. So I get 1/2 I get 1, I get 2, I get 4, and 8. And then I'm going to have -1, 0, 1, 2, 3. Our asymptote. We flipped our x and y, so what do you think our asymptote is going to be now? Yeah, it's going to be x equals 0. Intercepts, they also flip. So now I am not going to have a y-intercept, but I am going to have an x-intercept of 1, 0. You can see that in the table. You'll see it on the graph when we get there. So we just flipped all of our x's and our y's. We're going to graph this now. So when you have y equals 0, it is a horizontal line. When you have x equals 0, it is a vertical line. That's one of the important pieces in why I require you to have the x or the y equal to and not just a number. Because you have to state something so that we know you know what you're talking about. We're going to enter our data points, and then I'll start drawing the curve. Something I'll just point out here really quick, and I'll drag this right back, is I take this function over here, that's a little crooked, but that's fine. Inverse functions get reflected over y equals x. So you can see, and this would be a geometry thing, right? Reflection over this line right here. Inverse functions do that. Okay? So that's just a little bit extra for you. You don't necessarily need that. But so our graph is right over there. This graph right here is the first log that you've ever graphed. So this is the graph of log base 2, argument of x, and that equals y. How many points do you need for an exponential function? 3. And when you're doing that, I really don't want to see fractions. So these would be the 3 that I would really expect to see. Those points right there. When I'm doing a log, we actually only are going to require 2. Those would be the 2 that you have. So when you draw this, and I'll show this with a different color, I put this dot down, I put this dot down, I have my asymptote going there. I just start down below, go up, and then I would slowly kind of flatten off. I don't truly get flat over here because it continues to go on and upwards forever, but that's how you draw that log. Questions? The very bottom of your page, it says find the inverse of y equals 2x. I'm going to change one slight thing and say I'm actually going to call this f of x equals 2x. And then I'm going to change it to this. And we actually have a chapter where we go through solving inverses. So this is just a little intro. It's not going to be very detailed. But the first thing you do when you're finding an inverse is you just swap the x and the y. And then when I find the inverse, I have to solve for y. So this is where the log comes in. I look at my base. My base in this case is 2. So to deal with that, I'm going to take the log base 2 of both sides. So I get log base 2 of that, and I'm going to have log base 2 of that. And this is what happens. The log base 2 and the 2 cancel, leaving me with log base 2 argument of x is equal to y. let's think about what's going on here. That 2 right there is my base. It's still my base for the log. The base never changes. It's always present. This x got flip-flopped around, so I'm not going to deal too much with that at the moment. And the y also got flip-flopped around. And so I'm going to point to these then. So this is what we were solving. This was my exponent. And so that's the key. Logs equal exponents. That's basically it. Logs equal exponents. So if I'm using a log, I am finding an exponent. This x right here would be considered your argument, but you can think of it as your answer. So if I have 2y, that equals x, this is my answer, that's my exponent, this is my base. These two things just spin when we deal with logs. We're not going to tackle that today. We're just exposing you to that today. So in the future, it's maybe a little bit less. Any questions on that? Next page then. Start off by changing this to 3, because we already graphed log base 2 argument x. We don't need to graph it again. So we're going to make that a 3. But we're not using our calculator, so how are we going to pick our numbers? That means you actually have to look at the middle of your page. We are going to utilize these 2 properties. These 2 properties are essential to graphing. Everything for graphing logs, we base around those 2 points. This down here is helpful sometimes for graphing. We can use it, but it's helpful for when we're doing other calculations. So this is how it works out. Log base b with an argument to 1 equals 0. Well, logs equal exponents. So this is really an exponential form. B to the 0 equals 1. Isn't that an exponent property? All of the properties of logs are simply based off the properties of exponents. So if you know the properties of exponents, with a little bit of work, you can always get the properties of logs. So if we look at this one, log base 3 with an argument to 1. You read it like this: 3 to what power is equal to 1? Our property says it has to be 0. Just to make the connection for you. They are saying the exact same thing. The next one that is essential to graphing is log base b. Has an argument of b. And so this is equal to 1. Well, let's think about that. This is really saying this log is equal to that exponent, and that's my answer. So this is b to the first power equals b. 2 to the first is what? 2. 3 to the first is 3. So there's nothing really crazy going on with that. It's just that when we choose numbers, we are going to force our argument and our base to be the same. When we choose numbers, we're going to force the argument to be 1, doesn't matter what our base is, because then we always know the answer is 0. When I look at log base 4, argument 4, the answer is simply going to be 1. Yeah. So whenever these are the same, your answer is just 1. Some people are always like, heck, I'm not even going to remember anything mathematical for that. I'm just going to play a matching game. If I see the same number, I just put 1 down. If that works for you, okay. Last one we're going to look at. We utilized this property when we were dealing with solving for the inverse function. 49, what's another way I can write 49 out? Perfect. So notice our base is the same. Both the base of the log and the base of the argument are the same, so they cancel, leaving me with 2. When I look at this, I don't necessarily think of this property. I actually like to think of it as an exponent. I think 7 to what power is 49? So I jump around. And so if you know those facts, or if you have that reference sheet in front of you, you would just look for 7 squared, or you would look for 49 and see that it's 7 squared. So you would just take the exponent and put 2 there, and you would be done. Questions? Now we know enough to be dangerous to graph by knowing that. So I'm going to go back up to our log base 3. Remember, we changed that from log base 2 to log base 3. And we're going to choose our numbers. Based off the properties, what do I want to choose for x? I will take... I'll wait, actually. I want another answer. What number should I use for x?
For X.
For x. I get to choose x. Think about this. You have it on the middle of your paper.
23.
These properties right here. So, it doesn't matter what my base is. I'm always going to choose 1. Doesn't matter what my base is. I'm going to always choose the same base. So when I'm graphing this, I'm going to choose 1, and I'm going to choose 3. So this is how it looks. I would go log base 3 with an argument to 1. Now remember, this is really saying 3 to what power is 1? 3 to the 0 power is 1. So this equals 0. When I look at the next one, I'm going to have log base 3, argument to 3, and it goes like this. 3 to what power is 3? Just 1. So we use those properties, and they speed things up sometimes. So I'm going to put both points down. I'm not going to graph yet. So I got those 2 dots. For logs, we only look for 2 points based off those 2 properties. What's my asymptote going to be? If you had to guess, take a guess. Is it going to be y or x?
X.
It's going to be x.
Equals 0.
Is there anything up there that's different than the log base 2x? No. So there's nothing going to be shifting it. So it is going to be x equals 0. Now, on the next problem we are going to have a shift for the asymptote. We'll talk about that when we get there. My intercepts, I'm going to have an x-intercept of 1, 0, and my y-intercept, I just don't have one. This time. It's not every time, just this time. So we draw that vertical line. And then I'll go right next to it, and I will go up through the points. Erase. If I needed 3 points, what would be a third point that would be really nice to use? For x. Would be the last thing I like to use. Yeah, 9. So I'm going to write something on the board here to help us make a little connection. I'll actually do it on here since we're recording up here. 3 to the 0 is 1. We basically have that right there. 3 to the first is 3. We have that in our next line. So if I put 9 down, that would be 3 squared. And I know I flipped them. But so if I put 9 down here, my answer is going to be 2. So I would have a dot right there. Now you don't need that dot. I'm just throwing it out there to give you another experience with it. Questions? Last problem of the day for the notes. Sorry. if I look at this right here, my thought first goes to the two properties that I have. The first property I have says that this should be a 1. The next property says that this should be a 5. But if don't write this down, if I plug 1 right here, I would get log with a base of 5, and then I'd get 1 minus 3. That gives me a -2. I don't want that. So I can't just put the number I want right here. I have to put the number that's going to force this to become 1. So what number am I going to put in here? I'm going to put 4 in. Yeah. So I'm going to make this 4 because I know that when I do that, and I'll erase this and I'll show that, when I plug 4 in, I get 1 as my argument, and then it comes back to the property. 5 to what power is 1? 5 to the 0 power is 1. So I need to force so that my base is the same as my argument. So I need 5 to be in that argument. I need 5 to be in this parenthesis. So I have log base 5. What am I going to place in here? I have a -3. I need to get 5. What do you plug in? 8. Very nice. So you plug 8 into that. Realize we took our first graph that we did, and now we're shifting it, right? It's getting shifted to the right because of that -3. So I'll put those 2 points down, so 4, 0, and then I got 8, 1. I'll finish this off. And now I'm going to bring back something you've done in the past. In the past, if I gave you something like this, x minus 2 squared plus 3, that's a quadratic. If I asked you what the vertex was, you would tell me that the vertex is going to be 2, 3. Because you would do the opposite of x and you would do the same as the y. It's kind of the same with our asymptotes. So if I have an exponential function, whatever that c was, whatever that number adding or subtracting was, we did that for our asymptote. We shifted up or down based off that. For the logs, because we're attached to the x, I do the opposite of that. So my asymptote is going to be this number. It's what makes this 0 though. So it's really just 3. It's positive 3. It's always the opposite of that. Because what it comes down to again is it's whatever makes that 0. So this is going to be x equals 3. And so I'll also give you the point of advice. If you do this correctly, chances are it's just 1 behind. Okay? So I'm going to draw that line coming down. And then I'm going to draw this going up. Intercepts, we only have the 1. We have our x-intercept of 4, 0. We have none for the y-intercept. Y-intercepts happen when this number up here is positive, when it's like x plus 2. Because then that's taking this line and it's putting it at -2. So then I'm going to slide up and I'm going to cut through that y axis. What questions do we have?
So when we like putting in numbers to subtract, you always just trying to get back to 1, 2, 3, base and 1.
Yes, that's it. Those two properties. If you follow those two, you're always good. Hold up. Go to your homework now, folks. I'm going to do 6 problems with you. I'm going to do 3 on the front, 3 on the back. So the first problem that I'm going to do, they're not numbered, it's in the upper left corner. When is this homework due? Tomorrow. Tomorrow at 3. Not when you have class, at 3. So the first problem here is log 15, 15. Do you need your calculator for that?
No.
No. What's the answer?
1.
What? It's the matching game. If they're the same, that means they are 1. Again, that's because 15, this one right there, to the first power equals that 15. If I think about it in terms of an exponent. When I go to the next one, I have log base 15. I have an x right there, and I have a 0. So this is saying 15 to the 0 power is what? What's anything to the 0 power? 1. Thank you. So I would simply write x equals 1. There's not a lot of work on this first page. It's more so, can you do the calculation? And you're kind of done from there. The last one, this one's kind of tricky, is log base x with the 9 right there, and then a 2. So what this is really saying is x to the power of 2 equals 9. So what is x? 3. So x equals 3 here, because 3 squared does give me 9. Flip your page, or if you got it laid out, we're just going to jump to the other side.
You won't do anything with the 2?
Because 3 squared.
So on the next page, I'm going to look at F2. So the letters relate to the functions up above. There's 3 functions up above. There's F, G, and H. So when I look at F2, I'm looking at the first function in the upper left. So that is going to be log base 3, and then I get 2 plus 1. Now, if you write nothing down but the answer on this page, I will give you nothing for your package. So you need to make sure you show some stuff here. I get this. I always want to see you plug it in. Then I get to this step. What's my answer?
1.
Yep. My answer is 1. My base and my argument are the same. Therefore, this equals 1. So f of 2 is simply 1.
How do you decide which one to use again?
What letter is there? So this is f,
Oh.
so then it goes with f of x. The next one I'm going to do is h of 127. Now some of you are probably thinking, that's a big number, I want my calculator. If you have your reference sheet, you would be fine on this one. So h of 127 is going to be log base 5, and I have 127 minus 2 plus 5. What do you do first? Do you add numbers together or do an exponent first? So it's the same thing with the log. I do the log before I do any addition. So I'm going to deal with what's inside of my argument. So I get log base 5. I get 125 plus 5. 5 to what power is 125? No.
Would you ask?
3. Yeah. So 5 to the third power is 125. So folks, you know what happens to this? Gone. It is simply 3. So I get 3 plus 5, which is 8. Let's talk about that for a moment, because this is a point that gets confusing for people. If I wrote this down for you, and I asked you to solve that, you would say 9 divided by 3 is 3. Well, where'd the fraction bar go? Why did it disappear? Because we did the division, we did the operation. When I do the operation, this is gone. So I get 3 plus 5 equals 8. Does that kind of make some more sense? It's the same thing if I have 2 squared. Some of you might like to tell me that's 4 squared, but what happens when I square something? The square's gone. The operation is done. So that's what's happening now. I'll do one more with you. I'll let you pick. I would recommend you've done F, you've done H, but you haven't done G.
There's no G.
Pick one of the G's.
Do G 1.
Yeah.
Every class picks that one. You people hate fractions so much. I don't blame you. Actually, I kind of do.
Well, I'm already
So-
done with the packet. I'm just-
e to the 1/2. First thing I did, I just plug in 1/2 in for x. So I replace that x with 1/2. I ignore the -1 because I'm not doing anything with that. I'm dealing with my log. So I get log base 4. I get 1 right there, and I get -1. Now I've said this a few times, but you ignore that -1 till the end. It's the last operation you do. I still have people that will go ahead and say, oh, that's 0. It's not. They don't combine. You deal with your log. So the log, base 4, argument to 1, is 4 to what power is 1? 0. That's your answer. This is going to be 0 minus 1. So your answer is -1.
Can you keep that up?
Yes.
I got it.
I just need